So this is the OCR, and it's the paper 4 from May 2017, and it's the first 9-1 GCSE mathematics paper. Okay, so, and I've got, it's a calculator, is it? Yes, it is. I've got a calculator by my side, and I will say what we're doing. I'm doing as I use the calculator. So question 1, calculate that square root there. So what I'm typing on my calculator, then I'll write it here. I type this on my calculator, square root, and then I press the fractions button, which looks like this on my calculator. That one's shaded in and that one's blank. And then I've pressed 4.8 and then the x squared button, 4.8 and then the x squared button, plus, because that's a button as well, 3.6 and the x squared button. Okay, so I'll just catch up there, plus 3.6 x squared button. And then I press the downwards arrow so that there's a like a circular button here, and I press the downwards, so I press that bit. You can press up, left, right and down. So I've pressed down, and the bottom I press 4. And then I press equals. Okay, so the numbers are all, you know that they know where they are. So I've just put squares around the buttons, and it's come up as 3. Okay, so there's other ways of doing that as well. You could work out 4.8 squared plus 3.6 squared. Work out that total first of all, and then do the square root of that total divided by 4. That would also work. Okay, so for this next one, I'm going to press, I'll write here what I'm going to press. It's going to be fractions button. Mine's shaded in on the top there. The calculator that I'm using is a Casio FX 85 GT plus, but there are lots that you can use. Okay, so I'm using the fractions button, and then I'm going to press 1, and then I'm going to press the downwards. Okay, so I'll clear what I've got already. Fractions button, 1, downwards to get into the denominator of the fraction, open bracket, 2, and then 2, and then there's at the bottom of my calculator times 10 to the power x. So I press that, and then a 4. Close brackets. So I've done open bracket, close bracket, and then plus open bracket. It's going to be 5 times 10 to the power x, 3, close brackets, and then it's going to be equals. Okay, so plus open brackets, 5 times 10 to the power 3, close brackets, equals, and I've got the answer 1/25,000. Okay, so the length L of a steel rod is 8.3 metres, correct to 1 decimal place. Okay, complete the error interval for length L. So if it's been rounded off to 1 decimal place, that means it could be 8.25 to 8.35. Okay, if you notice here there's a less than, so it means it's less than 8.35, but not actually equals to 8.35, and 8.25 here. Okay, because if you think like there, that 5 would make that round up to a 3, and we don't want that, then it's less than that one. So at that point it would round up to, for this one here, it would round up to 4, but it's less than there, just less than by itself. Okay, number 3, write 504 as a product of its prime factors. So I can see straight away that 504 will divide by 2, but I can also see it's going to divide by 4. Okay, so let's say I've got a calculator now, so we've got 504 it's going to be 4 times 126. Okay, so 4 is 2 times 2. 126, I can see that divides by 2. That's because it's an even number. I knew this divided by 4. Well, I knew it divided by 4 because it was 500 and 100 divides by 4. So 500 divides by 4 and that extra one there. But then when it's 4 times 126, 126 is even, so it's going to be 2 times 63. You can do 126 divided by 2 on your calculator. And 63 is 7 times 9. 7 9s are 63. And 9 is 3 times 3. So putting all this together, we've got 2 cubed, 3 squared, and a 7. So it's 2 cubed times 3 squared times 7. I'll check that on my calculator. 2 cubed times 3 squared times 7 does equals 504. Next one, find the lowest common multiple of 180 and 504. So we've just worked out here the prime factorisation of 504. So we do the same for 180. 180, I can see that that is 9 times 20, which is 20 is 4 times 5, so that's 3 times 3, 2 times 2, and 5. These are all prime numbers. Okay, so 9 times 20, 3 times 3, 4 times 5. Yep. So we've got that 180 is 2 squared times 3 squared times 5. Okay. So what we need now, it's the lowest common multiple of 180 and 504. So it's the lowest number that 180 goes into and 504 goes into. So what we do is we compare the prime factors, and the lowest common multiple has to go into both 180 and 504. So it's got to have a 2 cubed. Okay, because if it's just 2 squared, 5 and 5, it's got to have 2 cubed. You've got to pick the highest. I don't want that one there. You've got to pick. I don't want that one there. Oh, what am I doing? It's got to be 2 cubed because 504 has got a factor of 2 cubed. Okay, they've both got 3 squared in there, so it's going to be 3 squared, and we need 1 5 and 1 7. Okay, so we've got to look for the highest power of each prime. So the highest power for 2 is 3. The highest power of the 3's is squared. 5 to the power 1 and 7 to the power 1. Okay, so the lowest common multiple, you've got to pick the highest power of each prime. Okay, and so on the calculator now, I'm going to do 2 cubed times 3 squared times 5 times 7. I've done that wrong. 2 cubed times 3 squared times 5 times 7. 2,520. Okay, so when you do the lowest common multiple, you pick the highest power of each, so cover all your bases for all of them. If you want this is to compare, if you want the highest common factor, you actually pick the lowest that goes into each. So the lowest would be 2 squared times 3 squared, and we wouldn't have any 5s because 5s only goes into 180, and we wouldn't have 7s because that only goes into 504. So you pick the lowest that goes into each. So it's because it's got to be common. Okay, so this is going to be 4 times 9, which is 36. Okay, so for the highest common factor, you pick the lowest. the lowest common multiple, you pick the highest. Okay, we don't need that one for this question. Okay, find the value of S when U is 12, A is 10 and T is 4. So S, that UT, that means U times T. So it's 12 times 4. And then it's plus a half. Half AT squared, that means a half times A times 4 squared. Okay, and you can run that straight from your calculator. 12 times 4 plus, instead of a half, I'm going to write 0.5 times 10 times, and instead of 4 squared, I'm going to write 16 because I know that's the answer. That's 128. Question 5. Mohs tyre pressure gauge shows a reading which is 12% higher than the actual pressure. What is the actual pressure when Mohs gauge shows 38.64? So the 38, let's see. So you've got 112, 1.12, okay, times the actual pressure is equals to 38.64. Okay, you've got the actual pressure, 12% higher, that 12% as a decimal is 0.12. So 1, that's the real pressure, that's pressure, and this 0.12 is adding 12% onto the pressure. Okay, so P is 38.64 divided by 1.12, because that's the times there. So times on the left, divide both sides, divide on the right. So P, 38.64 divided by 1.12, the actual pressure. Once I've done that on my calculator, 34.5. 34.5. Okay, number 6. Diagram shows a semicircle inside a rectangle of length 120. The semicircle touches the rectangle at A, B and C. Okay, so because this is a semicircle, 120, which is the length of the rectangle, is also the diameter of the circle. Okay, so that means that the radius of the circle is 60. So that means that this height is 60 metres. Calculate the perimeter of the shaded region. So we need that, and that, and that. Well, that is also 60 metres there. Okay, so we've got the two straight edges. So we need this here, which is a quarter of the full circle. So the circumference of the circle is pi times the diameter. Okay, and then our shaded area, and this is an arc. The arc that we need. The arc that we actually need is pi times d divided by 4, because it's a quarter of the full circle. Should we go right round there? Okay, so this is going to be pi times 120 divided by 4. So pi times 120 divided by 4, which is 94.2477. What we're going to have 3 significant figures. That's going to be more than enough. So just leave that there. So the perimeter that we need, the blue perimeter, is, I'm just going to change this pen to change it to a fountain pen. See what that looks like. This perimeter is going to be 60 plus 60 plus 94.2477. Okay, so I've got the 94.2477 etc. on my calculator already. So I'm going to do plus 120 for the two 60s. So it's 214.2477 etc. etc. And then it says it wants it to 3 significant figures. So 1, 2, 3. This one is less than 5. So it's 214 when it's rounded off to three significant figures. 214 metres. Okay. A, B, C, D are 4 towns. Here, look. A, B, C, D. B is, so they're all been measured in relation to A. So B is 25 metres east of A. So it's 25 metres there. If you remember, north, south, west, east. C is 25 kilometres north of A. So that's another 25 there. And D is 45 south of A. C north of A, D south of A. Work out the bearing of B from C. B from C. Okay, so I'm going to rip some of these out. Oh, I'll redraw the diagram here. The bearing of B from C. So because it says from C, we've got to put the north at C. Okay, and then B is down here. Okay, so the bearing, we measure clockwise from the north at C, because it's from C. So we measure clockwise from the north at C round to the line that connects B to C, the straight line. Okay, so across here, that's 25 metres, because that's there, which is this 25 here. And then down here, this is also 25 metres, because it's there, which is parallel there. So that's 25 as well, and that's 25. Okay. So because this is 25 and this is 25, when they're the same, this is 45 degrees. Okay. If they was different, you'd have to do, you'd have to use your calculator, depending on what the numbers are. So this part here, that is 45 degrees. This part here is a right angle. Let's just rub that out there. Okay, so we don't have to do this in our calculator because it's 25 and 25, that's 45, and that's 90 degrees. So the bearing is 90 plus 45 degrees, 90 degrees plus 45 degrees, which is 135 degrees. Now the bearing of D from B. So from B, so let's put the north at B. And then D is over here. I'm following this here. B's there, D's there. What we've actually got is that is 25 and that one there is 45. Okay. So we know round to there, that's going to be 180 degrees because that's to due south of B. So we need this extra here, this angle here. Okay, so we look at this angle here. That one's 45 metres and that one's 25 metres. We want angle, let's call that theta. Angle theta. We've got tan theta is the opposite over adjacent. Okay, so tan theta, opposite theta is 25 meters. Adjacent to theta is 45 meters. So tan theta is 25 over 45. Make sure your calculator's set to degrees. So the way I've done that is shift. I did shift, set up, and then number 3 comes up as degrees. Okay. So theta is tan inverse 25 over 45. You could cancel that fraction down if you wanted to, but I'm not going to do that just today. Tan inverse 25 divided by 45. Now I haven't used the fractions button because it's just one number on the top, one number in the denominator. So theta is 29.05 degrees. So the bearing that we want, D from B, is 180 degrees plus 29.05 degrees. That's to two decimal places. That's 180. So it's 209.05 degrees. We'll just say 209 to the nearest, because nearest degree. I've got the degree sign there, but I'll write it there. Okay. Number 8. The table shows the average number of customers per day entering a shop. So in the months January in 2015, January to March 2015, there's 119. So these are going up in tens. 1, 2, 3, 4, 5, 6, 7, 8, 10. Yeah, so it's just slightly below the second one. April to June, 210, 20, 30, 40, 50, 64, so it's close to the middle there. July to September, 368. October to December, 172. Yeah. October to December says 100, 10, 20, 30, 40, 50, 60, 72. Okay. Complete the time series below. I mean, I guess put the 216s in. So January to March, 113. Sorry, 130. 10, 20, 30. April to June, 304. 300's that sort of in the middle there. July to September, 381. It's just slightly above that line there. October to December, 192. Okay, so we can, do you know, I'd be tempted to dot it and use a ruler, but because I haven't got that, I'm going to use a line like this. Because I feel like it won't need to. Sorry. Try make them as neat as you can. Use a ruler. I would prefer to use a dotted line. Don't know what's happening there with that one. One last try. Just overarch it there. Anyway, I'm going to try again. I don't like the way that I've done that. Let's go above, because as soon as it wants to drop it below. Okay. But make sure it joins up. Okay. Right. Average number of customers per day. There's the year and month. Make two comments comparing the number of customers entering the shop in 2015 and 2016. And we can say, well, the first thing that jumps out. So the highest number of customers is always highest in July to September and lowest in January and March. So in both years, the highest number, there's always lots of answers to these. The highest number of customers occurs in July to September, and the lowest number occurs in January to March. Okay, I don't know if that's like too comments in one. But anyway, I put both in there because I wanted to say, like, so that is the number of customers. So it's always highest in, yeah. Now, if we look at across, I'll do this in another column. 119, 130, it's higher in 216. 264, 164, higher in 216. 368, 381, 172, 192. Okay, so we can say for each quarter, as in the quarters are January to March, April to June, etc. For each quarter, the number of customers entering the shop is higher in 2016 than the corresponding quarter in 2015. Okay, so I've done one, like the highest and lowest, and then I've compared across. So it's higher there, that one's higher there, higher, see it's always higher in, oh you just look at the numbers. Right, next page. Each week Dan drives 2 routes, route X and route Y. 1 week he drives route X 3 times and route Y twice, and he drives a total of 134 miles that week. So that's 3x plus 2y, x 134. Another week, he drives route X twice and route Y 5 times. So 2x plus 5y is 203. Find the length of each route. So this is going to be simultaneous equations. Okay, x 3 times is 3 times x, y twice 2y, that total is 134, twice x, 2x, 5y, 203. Okay, so simultaneous equations. What I'm going to do is I'm going to eliminate the y's first of all. So I'm going to multiply equation 1 by 5, the number here, that will give me 10 y's there, and equation 2 by 2 to give me 10 y's there. Okay, so what I've actually done, equation 1 is multiplied by the coefficient of y in equation 2, and equation 2 is multiplied by the coefficient of y in equation 1. Okay, and then that's actually going to help me simplify things. Okay, so it's going to be 15x plus 10y, and then add 134 times 5 on my calculator. And I'll call that equation 3. And then 2 times the second one, so it's going to be 4, 10, 406. 4x plus 10y is 406, and I'll call that equation 4. So now if I do equation 3, take away equation 4, what I'm actually going to end up doing is eliminating the y's, so I'll end up with one equation in just x's, and I'll be able to solve that to find the x. So I've got 11x is, say 15 take away 4 is 11. The y's cancel out. If I do 670 take away 406, 264. Okay, so x is 264 divided by 11. 264 divided by 11. X is 24. Okay. And then what we can do, we've got x is 24, so we can substitute it into equation 1 or equation 2. And then that will make this into an actual number, so we'll be able to work out the y. So let's say we'll substitute for x in equation 1. That's going to give us 3 times the 24. Equation 1 up here, look, 3 times 24 plus 2y is 134. So that means that's a plus there. Not 48, that's a 72 plus 2y is 134. So 2y, 134 minus 72, 62. So y is 31. And then I'll check with equation 2. 2 times x. So 2 times our x plus 5 times our y has to be 203. So 2 times our x, which is 24, plus 5 times 31. 2 times 24 plus 5 times 31 equals 203, which is what we want it to be. So I'm happy. Okay. Ooh, state an assumption that's been made in answering part A. Well, I guess it's that they're all I don't know. I just feel like it's that they're all exactly whole numbers. Not exactly sure what do you, that he only uses his car for that and nothing else, but but it says he drives that route 3 times that way. I'm thinking that it's 134 assumption that has been made. Oh gosh. Right, I'm going to say for now, I would say that the 134 miles and the 203 miles are exact and haven't been rounded off. I'll check the exam board answer rounded off to the nearest mile. I'll check the exam board answer and put in the comments if there's something different. There will be other answers as well. Okay, so on the 1st of November 2016, we had 4,200 trees in a wood, and then 1 year later, only 3,980 of these are still alive. It's assumed that the number still alive is given by the number of alive, n, is a, which a number, times r to the power t. Okay, write down the value of a. Right, so that when you've got a question like this, the value of a there is always the starting number. That's why it says just write it down. It's 4,200. Okay, it's always the earlier one, the one that comes first. So that's where the a comes in. I'll colour that in blue as well, so it's all linked together. Show that r is 0.94. Okay, so if we look here, I'll change my colour now for this. See, t is the number of years. And we've got 1 year here, because we go from 2015 to 2016. So we can say, we know, if we got n is a r to the t, n is the number of trees still alive. Look there. So we've got 3948. This is when 1 year later t is 1 and a is 4,200. So what we've actually got. That's the number after 1 year. Look, the T is T years after. Still alive. Well, 1 year later. I'll underline that yellow so they all go together. 3948 is the original 4200 times the common ratio. Times the ratio to the power 1. Okay, so we can say 4200 times R is 3948. So R is 3948 divided by 4200. 48 divided by 4200, and that is equals to 0.94, and it's exact, it's not rounded off. Okay. Show that on the 1st of November, part C now, the number of trees still alive is predicted to have decreased by over 60% compared with the 1st of November 2015. So the number of trees still alive is A, which is 4,200, times now R, we've got as 0.94, and then, so we're going to 2030 from 2015, so that's going to be 15, so T is going to be 15, which comes from, actually just 30, take away 15. So it's going to be to the power, isn't it? The T is to the power there. So it's going to be to the power 15. So the number still alive in 2030 is 4200 times 0.94 to the power 15, which is 166 0.2255, and it goes on and on. Okay. So the number of trees still alive, so we're going to say, we have to round this up because if you got the 0.22 of a tree, so the number of trees still alive, do we round that up or round it down, I wonder? We'll just leave it as it is for now. Let's see what the leave it as it is answer. We can't have 0.22 of a tree alive. So we're going to say 1660 alive. Okay, even if it was 0.5, you can't. I would still say that was 1660. Anyway, so we've started off with 4,200, and we've got 1660 alive. Now this is predicted. Number of trees still alive is predicted to have decreased by over 60%. So if we work out the percent still alive, it's 1660 divided by the original, which is 4,200 times by 100. So I'll do 1660 divided by 4200 times 100 is 39.52, etc., etc. So the number of trees still alive is decreased by over 60%. So still alive is 39.5. 100 take away 39.52, etc., etc. is equals to, so I'm doing 100 take away answer 60.476, which is greater than 60%. That's the percent still alive. There. As required. So we've shown that more than 60% have deceased. We've shown that the number of trees still alive is predicted to have decreased by over 60% compared to November 2015. Right, question 11. Triangle T is drawn on a coordinate grid. Translate triangle T using the vector -3, 1. Right, so the top one is the horizontal motion and the bottom one is the vertical. So each corner, -3, 1, 2, 3, and then plus, and it's +1 vertically. Okay, so that top corner goes to there. -3, 1. This one, -3, 1. So go 1, 2, 3 for the -3, 1 up. And this one, 1, 2, 3, -3, 1 up. Right, so we don't need that line in there. I was just sort of showing you where I was going with this. And this looks like this. Okay, quite often call that T dash. Okay, so that's T dash 3. Describe fully the single transformation that represents a rotation with centre 0, 0 of 180 degrees, followed by a rotation with centre 0, 0 of 90 degrees clockwise. Well, do you know, if we're going to call this 0, 0, just imagine if we've got something that's a rotation of 180 degrees, so it's going to go around to there, followed by a rotation clockwise, that's clockwise there. So you could actually say it's going to be a rotation. So we do 180 followed by 90, you could say it's 270 degrees clockwise. And it's the same centre, so you can say it's with centre 0, 0. You could also say 90 degrees anti-clockwise with a centre 0, 0 as well. Okay, so you don't really need to do that to the triangle above because you can see what's going on quite easy. Alright, so these axes now, reflection in the x-axis. We've got something here, gets reflected in the x-axis. And then reflected in the y-axis. And then the single one. So what I've done there, I've taken, say, this point here, rip that one out. I did that second point because I wanted to exaggerate it a bit. Reflected in the x-axis, then reflected in the y-axis. Can you see that is I'll just pause then to just check my it's going to be a rotation. I'll do it with this triangle up here. I can see it there, but you might see it here. Reflection in the x-axis. Sorry, don't need that there. Reflection in the x-axis. This here. Reflection in the y-axis is going to take it over here. Okay. So can you see that that's going to be a rotation of 180 degrees? With your tracing paper, 180 degrees centre 0, 0. But you could trace this first triangle here. This is where it ends up after the reflections. And then if you rotate it 180 degrees, you'll see that it ends up there. Okay, so this is a rotation. 180 degrees. When it's 180 degrees, you don't need to worry if it's clockwise or anti-clockwise. It'll be centre 0, 0. Number 12. The cumulative frequency graph shows the speeds in miles per hour of vehicles passing a 40 miles per hour speed limit sign on a road. Right, so we've got the speeds along here, and we've got 80 vehicles, and so we've got, say, 10 of them are doing, just getting a feel for what's going on here. So it's how fast these vehicles are going when they pass this speed limit sign. Okay, so yeah. Right, a speed camera will be installed if more than 30% of vehicles go over the speed limit of 40. Use the information from the graph to decide if a speed camera should be installed. So 40 miles per hour is here. We can say, if we read it off here, so if we do this as the 40, if we read this off here, we've got these vehicles here are the ones that are going higher, 40 or more. Okay, so we've actually got 25 vehicles. Is that there? There's 25 vehicles there. 80, take away 55, 25 vehicles are going over 40. So it's 25 out of, and not the maximum, it's 80. Times by hundreds, turn it into a percentage. 25 divided by 80. Oops. 25 divided by 80 times 100. 31.25. Okay. So, a speed camera will be installed if more than 30% go over the speed limit of 40 miles per hour. So, whoops. A speed camera, which is greater than 30%, should be installed. Okay. Number 13. Rashid drives his car along the road passing through two sets of traffic lights. The tree diagram shows the probabilities of the lights being red when he reaches them. Okay, complete the tree diagram. So the first set here, if it's 0.6, it's going to be red. It's going to be 0.4, and that comes from 1 minus 0.6. It's 0.4. So this one here, 0.3, that's come from 1 minus, I don't need to write that again, do I? 1 minus 0.7 is 0.3, and this one is 0.8. Okay. Write down the probability that the first set is not red. So that is the 1 minus 0.6, which is 0.4. Given that the first set is red, write down the probability that the second set is not red. Given that the first set is red, write down the probability that the second set is not red. 0.7. Work out the probability that both sets are not red. Sorry, that one there, that's my answer for part C. Part A is on the diagram. Part B is that one there. And part C is there. So for part C, given that the first set is red, write down the probability that the second set is not red. 0.7. Work out the probability that both sets are not red. So we need not red and not red. So when we go down a branch like this, we multiply the two probabilities together. So it's 0.4 and 0.2. 0.4 times 0.2. So it's not red and not red. So it's that one and that one multiplied together, because that's not red and not red. So that is D. So it's 0.08. And work out the probability that at least one set is not red. So we've either got red and red, red, not red, not red and red, not red, not red. That's all four choices. Okay, so the probability that at least one set is not red. So that is there, and that is there. So at least one is not red. So we've got one not red, another not red, and two not reds there. So we want those. We don't want that one. because all four of these will add up to 1, it's going to be 1, take away the probability of red, followed by red. So it's going to be 1, take away red, and red is 0.6 times 0.3. 1 minus 0.18, so it's going to be 0.72. Okay. Number 14. How many questions are there? 15, 16, 17, 18, 19. I think there's 20 pages. 20 pages, 20 questions. Right. Keep going. Number 14. The diagram shows triangle ABCD with D on AC and E on AB, and DE is a straight line. AD is 28, AE is 41, DE is 22, BC 64. Okay, calculate the length of CD. Okay. Right. So we need, what do I need? Length of, I've got too much colour in there now, let's rub some of that colour off. Right, I need the length of CD. Just thinking how to do this efficiently. So what I see here is that I could use the because I've got 3 sides here, I can use the cosine rule in reverse to work out this angle A, because then I've also got angle B, and I've got this here, so eventually I'll be able to use the sine rule to work out this full length here, and then I can take, that's my thinking. Okay, so I'm thinking out loud there. So I'm going to start with this triangle here, and I'm going to work out this angle A. Now, if you remember, A squared equals B squared plus C squared minus 2BC cos A. And you need to remember that for your, I don't think it's in the formula, it is in the old days, they used to have that in the formula sheet. Let's have a little look here. No formula sheet. Back to page 14. Alright. So you've got to memorise that. So I've memorised that. So we can actually say if we add 2BC cos A to each side, and we take away B squared plus C squared, take away A squared from each side. Okay, so we add that to each side, so it comes up there. But we also take away A squared from each side. We rearrange it to get that. So cos A is going to be B squared plus C squared minus A squared over 2BC. Okay, so cos A. Now, B squared, that's angle B there. Oh, sorry, we're on this one here. Right, we're using this one here. So we've actually got cos A, well, we've got D and E here. So cos A is going to be D squared plus E squared minus A squared over 2DE. So I've replaced, because in this here, I've replaced D for B and E for C. Okay. So cos A, now lowercase d is 41, it's the length opposite D. So it's 41 squared. And then lowercase e squared is the length opposite e here, plus 28 squared minus, and lowercase a is opposite the a, so it's 22 there. This is going to be over 2 times 41 times 28. So, therefore a is cos inverse of 41 squared plus 28 squared minus 22 squared, 1981, 2 times 41 times 28, 2296. Okay, so shift cos inverse 1981 divided by 2296, close brackets. So angle A is 30.367 ... degrees. So there's more of it. Okay. What do we need? The length of CD. So there, the cosine rule has got us the size of A. Now we're going to use the sine rule. So this length here is lowercase b because it's opposite angle B. This length here is lowercase a because it's opposite cosine A. And we want B, so we can say, right, write down what we want first of all. We want B divided by sine 72 degrees. If you remember, that's the cosine rule. The sine rule, I'll just write it here, even though we're using it down there. B over sine B, A over sine A, C over sine C. Or you can do it before you up. Sine B over B, sine A over A, sine C over C. If you want, because we want the side, I've used this one with the side in the numerator. And then A over sine A, so it's going to be 64 over sine, and I'm going to keep my answer accurate. So I'll use the answer button on the calculator because it's there. So therefore B is going to be 64 divided by sine answer times sine 72. I'm going to do that now on my calculator. So 64 divided by sine answer, close bracket, times sine 72, close bracket. B is 120.4 ... meters. I'll just put to 1 dp. Okay, and we actually want CD is now equals to B take away 28 is equals to answer, my new answer, take away 28. Take away 28, it's already on the calculator, 92.4 metres to 1 dp. Okay. And we'll move on. Number 15. The graph shows the speed v meters per second of a car at time t seconds. Okay, so at 1 second it's here. Look here, between 5 and 6 it's reached 10 metres per second, etc, etc. And by 10 seconds it's reached 30 and everything in between. So when t equals 7, let me zoom in. It's looking like, could count the dots. So that's 15, 10, 11, 12, 13, 14. I don't know, it's about 14, just 14.9. let's just call it 15. I think I'll check the answers there. It's slightly below, but yeah. Right. 15 metres per second. I think it's supposed to be 15 that. Right, it's claimed that the car has accelerated from 0 to 60 miles per hour in the first 10 seconds. Does the graph support this claim? Show your reasoning. Use 1 mile is 1.6 metres. Well, at 0, it's going 0 metres per second, which is also 0 miles per hour. So the first bit's right. Okay. So we can say it's going from 0. So now we need to check now. So it's doing 30 metres per second after 10 seconds. Is 30 metres per second, which is what we need here, is this 30 metres per second equivalent to 60 miles per hour? Okay, it is at the first 10 seconds, so we don't need to worry about the 10 here. So we need to, is 30 metres per second, we need to know, is 30 metres per second, is 30 metres per second equivalent to 60 miles per hour. Okay, so 30 metres per second. If we do 30 metres per second, if we multiply it by 60, that's going to give us a 30 times 60. That's 1,800 metres per minute. Okay, we want to build up to hours. So multiply by 60 again. It's 108,000 metres per hour. Okay, so it's doing 108,000 metres per hour. So now we need to know is 108,000 metres 60 miles. Okay, and it says 1 mile is 1.6 kilometres. Okay, so 108,000 metres per hour. So this row we've sorted out the seconds into hours. This row we're going to turn the metres into miles. So 1,000 metres is a kilometre. So we divide this by 1,000. That's going to be 108 kilometres in an hour. What I've done there, times 60. I didn't write down what I was doing there, times 60. So divide by 1,000 is turning the metres into kilometres. And then every 1.6 kilometres is 1 mile. So we've got to divide this by 1.6, because every 1.6 of them. Okay. Sorry. And divide by 1,000. I didn't do that. I did that one in my head. And then divide by 1.6. So that is 108 divided by 1.6 is 67.5 miles per hour. Okay. Yeah. So the car has accelerated to 60 miles per hour in the first 10 seconds. It's actually before 10 seconds, but it says it has done it within the first 10 seconds. By 10 seconds as if it's actually doing 67.5 miles per hour. So, yeah. So let me just see, 60 miles per hour. I'm just going ahead. 60 miles per hour, 60 miles, and 60 times 1,600 is 96,000 kilometres per hour. 96,000 metres per hour. So So if we divide by 3,600. Yeah, so I've just worked out there. It's not part of the question, but it's 26 2/3. So it's around about there. So it actually got to 60 miles per hour after about 9 seconds. But anyway, so it has done it there. Use the graph to estimate the acceleration at t equals 7. Now, the acceleration at t equals 7, we've got the acceleration is the rate of change of, so it's rate of change of the velocity with respect to time. So we have to draw a triangle that's touching the curve at t equals 7, and I've done it to spread out across these 2 seconds here. Okay, and it's the steepness of this curve when t equals 7 will give us the acceleration. Now the steepness is the height divided by the width. So this height here, this is looking like about 8. Oh, when you zoom in a bit. Looks like about 8.5. And there, that's 2 seconds. So estimate the acceleration is actually 8.5 divided by 2, which is approximately 4.25 meters per second. 4.25 meters per second squared. Okay, so at that point there, it means the curve, the steepness, and this is called the tangent to the curve. The steepness of the tangent to the curve is 4.25 approximately meters per second every second. Okay, so that's how you do that. Basically, you draw this triangle, touch in there, and you work out the height and the width. Now I picked 2, but you know, if you wanted to do a wider triangle to see, that would be fine too. I know. The speed of this car is directly proportional to the square of the time. Find a formula linking v and t. So we can say the speed, v, is directly proportional. So that means it's a multiple of t squared. Okay. Now this is the one I'm going to use. When t is 10, v is 30. And that's going to help me work out the k. So directly proportional. So v is the speed. Directly proportional means it's a multiple of, and the square of the time. So it's the time squared. So v is 30 when t is 10, v is 30. K times 10 squared. T is 10. Okay, so K, so it's K times 100. So K is 30 divided by 100, which is 0.3. So we've actually got V is 0.3 T squared. Georgina says that the graph shows that the speed of the car will continue to increase after 10 seconds. Make one comment to show that this statement is incorrect. We've got no information at all about the speed of the car after 10 seconds. So we can only talk about between 0 and 10 because it's reached 67.5 miles per hour. You know, it may go faster if it's in a 70 miles per hour zone, but it may have to come off the motorway and slow right down. So we can't, the graph only, we really don't know, only gives information about the speed for the first 10 seconds. We cannot deduce anything about speeds after 10 seconds. Okay. So write x squared minus 10x plus 16 in the form x plus a squared plus b. Okay, so what we say here, the a is always half of this number with the same sign. Okay, so we can straight away say it's x minus 5 squared, because it's minus 10, plus a is minus 5. We divide that by 2. Okay, so I'm going to do this as an aside. You might not necessarily have to do this in the future, but we've got x minus 5 squared. So x minus 5 times x minus 5. So it's x squared minus 5x minus 5x. So x minus 5 squared looks like this. X times x, x squared. X times minus 5 minus 5x minus 5x. And then this is the important one. Well, they're all important, but this is minus 5 times minus 5, which is plus 25. Okay, so this is x minus 5 squared, and it's actually equals to x squared there minus 10x plus 25. You see? So this bit here is going to give us x squared minus 10x but plus 25. Well, we actually only want plus 16, and we've got plus 25, so we've got to take away 9. And that's our answer, x minus 5 squared minus 9. Okay, that's called completing the square. It doesn't say that in the question, but just might as well put it in for completeness. Boom, boom. Describe fully the graph which has the equation x squared plus y squared equals 9. Well, a circle always has equation x squared plus y squared equals r squared, and the circle is at centre 0, 0. So this is just something that you need to recognise. This, if it's x squared plus y squared, it's a circle, centre 0, 0, and then this is the radius squared. So you actually say this is a circle, centre 0, 0, radius 3. Square root of 9 is 3. Solve by factorisation. Okay, so there's lots of ways of factorising this, and your schools, I've known schools teach quite algorithmic ways to teach this. So now the way that I was taught it, first of all, I was told, right, so it's 2x in there and it's x in there, and that's going to give us 2x squared. Okay, and then there are a few ways of doing this. I just don't know which way is best to teach. But I'll just teach it the way that I was taught. If you know a better way, brilliant, use that. I know better ways as well. Yeah, but it's very easy to get the different ways muddled up. So anyway, what I've got so far is 2x squared, so that's sorted out. So these two numbers here have to multiply to make minus 12. Okay, so to multiply to make minus 12, you've either got plus 1, minus 12, minus 1, plus 12, plus 2 and minus 6, minus 2, plus 6, plus 3 and minus 4, and then minus 3 plus 4, And then we've got them all reversed as well, because one of them is going to be multiplied by 2. So the one here, we want to make minus 12, which is going to be that number times that number. Okay. But this number, when we're working out the 5x, has to be doubled. So order is important with these ones. So basically, plus 4, minus 4, plus 6, minus 6, plus 12, minus 12. Okay, so I've just got to systematically, at this stage, think about what goes in there. If minus 12 is in there, so if we've got minus 12, we get plus 1 and minus 12 in there. There's going to be plus 1 minus 24. It's not going to give us plus 5. Okay, we don't want that one. Then if we change it to minus 1 and plus 12, minus 1x plus 24x doesn't give us 5. Okay, so those two have been checked. Okay, plus 2 minus 6. So we've got minus 12x plus 2x minus 10x. That's no good. Next one, minus 2 plus 6 plus 12x minus 2x is 10x, not 5x. So that was no good. Let's try 3 and 4, plus 3, and then minus 4. So we've got plus 3x minus 8x is minus 5x. That's not what we want. Let's try the next one. Minus 3 plus 4. So can you see that we now got minus 3x plus 8x does make 5x. We've also got minus 12. We've also got 2x squared. So that is our answer. Okay, there's only one answer, so all these others could be rubbed out. Okay, so that's one way of factorising it, trial and improvement. Now you do start running through these quite quickly in your brain with practice. I went through them more systematically there. Okay, now another way to do it, one algorithmic way that I used to teach when I was a teacher. So if we've got 2x squared plus 5x minus 12 equals 0. Okay. What you actually do, you multiply these two numbers first of all. 2 times minus 12 is minus 24. Okay. And then what you need to do is you need to find two numbers that multiply to make minus 24 and add to give 5. Okay. So this is one of the algorithmic ways that I alluded to before. So this is actually going to be 8 and minus 3. Okay. So you start by multiplying these together, minus 24. Then you find two numbers that multiply to make that and add to give the middle number. And it's 8 and minus 3. Because 8 times minus 3 is minus 24. And 8 plus minus 3 is 5. So what you do when you've got that, you say it's 2x squared. And then you separate this 5x out this way. So it's plus 8x minus 3x minus 12 is 0. And then you factorise these two as much as you can. So it's 2x times x plus 4. And then it's minus 3 times x plus 4. Okay. So it's 2x times x plus 4. Because these both divide by 2 and they've both got a factor of an x. So So 2x times x is 2x squared, 2x times 4 is 8x. Both of these divide by minus 3, and then you've got x plus 4. So this is actually 2x minus 3 times x plus 4 equals 0, which is, you either do it that way, which is looking at every possibility, or this is an algorithmic way of finding the answers. Okay, this way is probably quicker. So, yeah. So now, I'm going to rub that out. Okay, so when you've got this, you've got two factors multiplied together to make 0. So either the first factor is 0 or the second factor is 0. So you either can say 2x minus 3 equals 0. So 2x is 3. So x is 3 divided by 2, which is 1.5. Or we can say x plus 4 is 0. So therefore x is minus 4. Okay. So you may know another way of factorising this as well. Now this one here, it says 2dp, you're going to need to use the quadratic formula. It's got 3x squared plus 2x minus 3 equals 0. The quadratic formula is ax squared plus bx plus c equals 0. Then x is minus b plus minus the square root b squared minus 4ac, all divided by 2a. Okay, so x is minus b plus minus the square root b squared minus 4ac, all divided by 2a. A is 3, minus b, b is 2, minus b plus minus square root b squared minus 4 times a, which is 3, times c, which is minus 3, over 2a. You have to memorise that formula. It's minus 2 plus minus the square root of 4 plus, and this is 36. It's plus because it's minus minus, and then 12 3 is 36, divided by 6. So I'm going fractions button up my calculator. Minus 2. I've seen some people not put they just put minus 2 to the left. The minus 2 is on top of the fraction. Plus the square root, and that's going to be 40 under there, divided by 6. So to 2 decimal places. The plus 1 is 0.72, rounded off. And I'm going to go back into my fraction and turn the plus to a minus. And it's minus 1.39. Okay, so that's all on the calculator. 19. We're nearly there. Here are the first 4 terms of a sequence: half, 4/3, 9, 16. Find the nth term of this sequence. Okay, so the first term is 1 over 2. The second term is 4 over 3. Third term, 9 over 4. The fourth term, 16 over 5. That is n. That's the term. So if we've got the nth term, this is actually 1 squared, 2 squared, 3 squared, 4 squared. So this is going to be n squared. And then this is always 1 more than here. So it's n plus 1. So you can say the nth term is n squared over n plus 1. Oh, here are the first 4 terms of a quadratic sequence. The nth term is an squared plus bn plus c. Find the values of a, b and c. Okay, so 2, 12, 28, 50. So we're going to start by finding the a here. Plus 10, plus 16, plus 22, So the first differences are there, the second differences are 6. So what we do for the A is half of the second difference. So we can say A is 3, and that means it's 3n squared is part of this sequence. So now we've got 2, 12, 28, 50. If we do 3n squared, so this is going to be 3 times 1 squared, which is 3. 3 times 2 squared, which is 12. 3 times 4, 3 times 3 squared, which is 27. And then 3 times 4 squared, which is 48. Okay. So we know 3n squared is part of the sequence. So I've worked out what 3n squared is for each place. So we take that away now. We do 2 take away 3 is minus 1. 12 take away 12 is 0. 28 take away 27 is 1. 50 take away 48 is 2. Okay, so we've sorted out the A and we've taken it away. So now we're left with, this is what's left is a Bn plus C. So there is plus 1, plus 1, plus 1. If it's plus 1, this means that here we don't halve it. The B is actually this here, 1. Okay, so this means that Bn, or 1n, is part of the sequence. And then 1n, that's 1, 2, 3, 4. So we take away the 1n, minus 1, take away 1, minus 2. 0, take away 2, 1, take away 3, 2, take away 4. And that means that minus 2 is the constant there. Okay, so it's work out the second difference, and half of it gives us the n squared. Take away that an squared to see what's left, and then look at the first difference, and it's that actual number, it's the multiple of n, and then, so this is 1 times 1, 2 times 1, 1 times 1, 1 times 2, 1 times 3, 1 times 4, take that away, and what's left is the constant there. Alright, got to the end of this. Okay, the graph shows the speed in meters per second of a particle over the first 4 seconds of motion. Use the graph to estimate the distance travelled by the particle in 4 seconds. Right, so the distance is the area, so we need to estimate the area. Okay, so I feel like, need to make a triangle here. Oh, it's the area. Look, it's an estimate. There's a triangle there. To make this into 2 trapeziums here. And this is another trapezium. I'm happy with that one there being. Let's do that one as halfway. There's a triangle. Let's do a trapezium there. Okay. So the distance is the area under the curve. That's on a velocity time graph. Okay, so there. So 0 to 1 second, that's going to be a half base times height. So the first one, between 0 and 1, is going to be a half times the base times the height, which looks like 2, 4, 6, 8. I would say 3 meters per second. How accurate if I'd drawn that there? Maybe 2 point. It's closer to 2, isn't it, than 3 there. So that 0.2. So this one here, 0.7. This one here is actually 2. And that one there is actually 16. So I've actually worked out these heights, 0.7. That one's actually 2. And that one is actually 16. And that was 1.5 there, wasn't it? Right, so 0 to 1, a half base times height. So it's 0.2 divided by 2, 0.1 meters. Between 1 and 1.5, so it's a half. Now this is a trapezium, so it's the half the sum of the parallel sides times the distance between them. Half of 0.2 plus 0.7 times the distance between them. That's the way the formula goes for the area of a trapezium. So it's a half of the heights, 0.2 plus 0.7 times 0.5. I don't have a calculator. 0.5 times 0.9 times 0.5. 0.225 meters there. The next one, 1.5 to 2. A half of 0.7 plus 2. Half the sum of the parallel sides times the distance between them. Here. So that is now going to be 0.5 times 2.7 times 0.5. 0.675 meters. And then between 2 and 4, did I say? No, that looks like a trapezium. Half of 2 plus 16 times, no, this one, so it's a half the sum of the parallel sides times the distance between them, so that's times 2. So that's going to be 0.5 times 18 and then times 2. 18 meters. We'll add all these together. 0.1 plus 0.225 plus 0.675. I didn't round those off because I could see that they were going to cancel. So that was okay for me. So 19 meters. And that completes the first one.